he's not speaking of the Arabic, huh?
Exactly.
Right. Okay, let's start now. The date?
25.
Right. You got that? Indefinite integrals. That's what we're having a look at now.
Antiderivatives.
Yeah.
It's like when we switch the derivative.
That's it, yeah. Now, this lesson and the next lesson is pretty straightforward. There's nothing too difficult in either of them. But then tomorrow's lesson will be a little bit trickier. So, let's have a look at an example here. Suppose I have x squared and I differentiate it, I get 2x. Right? Mm-hmm. So the reverse process, we can call it an antiderivative, going backwards. Okay, but there's a small catch. Suppose I have x squared plus 1. The derivative? 2x plus 0. So the antiderivative of 2x is x squared plus 1, which is different. So this gives us a problem. When we reverse the process, there's possibly a constant we've lost in reversing the process. So in this example here, we say the antiderivative is, well, I should say antiderivative of 2x is x squared plus a constant. We don't know what that constant is. We just know that there's a constant we could have lost. Okay? So, by looking at all the rules we've done last week, we can produce the reverse. We can make them opposite, so to speak. But just before I do that, a little bit of notation. The symbol to me in calculate the antiderivative is this symbol. Yeah. This means what is the antiderivative of 2x? And the answer here was x squared plus c. This is also called the integral. The integral is another word for antiderivative. Technically, they're not the same thing, technically, but for our purposes, they are. Yeah. Yeah. Oh, for integral? Yes. Beyond this course, though. Yeah. But you're right. Just like with first principles, there is also a sort of first principle definition for integrals as well. Okay, can we look at the table now? Yeah. We will produce a table with all these integral rules. Now, if you look at all the rules, you discover that they're the exact opposite of the previous table. So, for example, if I want the derivative of x power n, I bring the power down and reduce the power. If I do that backwards, I increase the power and divide instead of multiply. Let me show you. Can I scroll down? Yeah. So, here is the function, and then here is its antiderivative, its integral. So the first one is xn, and this becomes xn plus 1 over n plus 1 plus c. Increase the power by 1, divide by the new power. Okay? Next one we'll do is cos ax no, I don't use the letter A. What did I use last time? K, wasn't it? Cos kx. That will be sine kx. Not negative, but this time over k. Sine, oh, thank you, plus c. Sine kx will be minus cos kx over k plus c. What else did we have? Oh yeah, we had e kx. Yeah, it'd be e kx over k plus c.
What if it was
Log will be done much later. There's a special rule for that one. Yeah. Yeah, sorry.
What if there's constant before the
Yeah, it doesn't matter. So, like, you mean if you had a constant here, then it just goes here. 1 over cos squared kx be tan kx over k. Let's see. Oh yeah, 1 over, let's say, ax plus b. That one would become 1 over a log ax plus b plus c. And the special case here is 1 over x becomes log x when a is 1 and b is 0. That's the special case. Any other rules I missed? Have I got, apart from log, have I got all the functions we did last week? Sine, cos, e, cos squared, and 1 over ax plus b. That's them all in the table last week, isn't it?
I have a question about the derivative of log. Is the derivative of log and 10 the same?
No. The base has to be e.
So that's for them.
Oh yeah, anytime I'm using log is base e. Yeah, yeah. Let me think. John, that's an interesting question because it hasn't actually come up on the exam, even though it's not difficult. What do you do if the base isn't e? So I'll very, very briefly just put that on the side. I'll go back to this in a sec. Guys, suppose you had a log base 10x and you want the derivative. It's not 1 over x, okay? First you should change the base to base e. Do you remember how to do that? This becomes log base e of x over log base e of 10. Or to be extra clear, that's 1 over log base e of 10, log base e of x, or to be super, super clear, that's 1 over ln 10, ln x. And now the derivative will be 1 over ln 10 times 1 over x. So, Matar, you can see having a base which isn't e basically adds this extra piece into the answer. So you could figure out a rule for this. If you have y equals log base b of x, then the derivative here will be 1 over ln b times 1 over x. So it's actually, I've never seen this one in the exam, but now that I think about it, I realise there's no reason they couldn't do this in the exam because it just needs a rule of log, and then you can get the derivative. Do you want to write this down, actually?
Yes.
Yeah, okay. Got that? Continue. Or go back to the table.
Wait, sure, one
No.
second.
Continue.
Yes.
Yeah. Okay. Does everyone have this table? You need the table? Yep. Who am I missing now?
Joshua.
Joshua?
Joshua.
Yeah, that's his name. Don't wear it out. I feel like there's a little bit of a gap in this part of the room here. No? Okay. Right, have you got that? Yeah? Yeah? Okay. Right, let's have a look at an example. Let's say I want to integrate something like x cubed plus x squared plus x plus 1. Okay, so using my first rule, that will be x power
3 plus 1.
yeah, which is
4.
4 over
4.
plus
Plus C.
x cubed over 3 plus
Over 2.
plus x, yeah. Because if it helps, this is a little bit like x power 0 plus c. Yeah. Okay, let me give... No.
Even for the previous, for the rules you showed us.
Yeah. Okay.
1 over ax plus b. Shouldn't take. Where did this go? 1 over x.
It's multiplying it.
So shouldn't it be 2a plus
Mm-mm.
2ax plus a?
Mm-mm-mm. I think this is right.
So this would go down and down and down.
The proof, I can't do it until the next semester. You have to trust me on this one. But if you like, these rules are in the formula book as well, if you need to check them. You know the formula book's on Moodle. Yeah. Okay. Continue?
Mm-hmm.
Oh, it's taking so long today. You got it? Yes? Yeah. Okay. Let me give you one to try.
Interesting.
You must expand it and simplify before you can do anything. Give this a try. You know what? I'll make it a smidge easier. Just put the square on the top bracket, okay?
Okay.
So, what I mean is, I actually just need you to square open the top bracket. We'll keep the bottom just as simply as.
Okay.
Yeah.
Mm-hmm.
Okay, do we have answers?
Yeah.
Yeah? You missed the log. Yeah. So this becomes on the top 1 plus 2x plus x squared over x dx, which becomes 1 over x plus 2,
Oh,
yeah, 2x over x plus x dx, right?
Mm.
Now we can integrate log x plus, yeah, plus c. Okay, write that down if you didn't get it.
Wait, it's just
2x over x. Looking for me? Looking for them?
Just so we're all on the same page, it's here at 1 for academic skills. We got that message from Colin.
No. My timetable says 2.
Timetables jump between 1 and 2, drop offs is on Fritz. Connections between the two. Should be 1, it should be here. Yeah, you probably saw that this morning. And then it changed to 2 o'clock. And it's back to 1 again.
Do we need our laptops?
Yeah, we have it.
Mm.
That doesn't sound like a question, that sounds like a statement.
Yeah.
Anyway, it's here, it's at
And what's the topic?
topic is materials and methods for the combined language.
So am I in that?
You're alright.
Good. Okay. So I don't need to be here then.
You don't.
So then I care very little about it now.
Yes.
Thanks for clearing. Do the physics students know? Because
No water over there.
okay, super. Thanks. That's good. 'Cause I didn't feel like having that class today. Just yeah. Because then I'd have 2 hours here and then an hour of that.
Oh, yeah.
No, thank you. Thank you. Yeah.
Change from just to x.
Say again.
From 2 to x.
From 2 to 2x. Yeah. So we didn't really go into too much detail with that one. So if you just have 2 and you want to integrate the number 2 by itself, okay, that's a little bit like 2x power 0, because x power 0 is 1. And then the rule is increase the power, divide by the power. So, Dasha, what you can just remember, a lot of people just remember constants become constant x. So like 2 becomes 2x, 4 becomes 4x. Is that okay?
Yeah.
Yeah. Let's do another one. Let me give you one not quite as hard. Integrate this. Don't say log. Yep. Okay, we got answers? What should I do first?
Bring the thing.
Yeah, well before I do anything, I should change the power to minus a half, yeah? And now, increase the power by 1? Divide by the new power? Plus c? So this is equal to, if I simplify the answer, let's see. Yeah, question, yeah? Yeah, the exam often says not, the exam often doesn't care if you simplify or not. No, not always, but most of the time, no, it doesn't matter. Yeah.
Why to square root x?
X power half is square root x, isn't it?
So why the half?
1 divided by a half is 2. 1 divided by a half is 2. Yeah? Okay. The other one I want to do. So in all the examples we've done so far, we have not found the C. Because we can't. We don't know what it is. But is there any way we could find the C? Like what would I have to give you, or what would have to be different for you to be able to get the C? Yeah, go ahead, Mark. That's the next lesson. So something else. It's kind of like limits. It's kind of like x and y. Yeah.
X goes to.
Yeah. Infinity or something?
No.
Needs
to be given.
Yes,
Yeah.
I have to give you a coordinate. I have to give you an x and a y. Yeah? So let's take this as an example. Let's say I tell you the derivative, and by the way, if I didn't tell you this already, you can write the derivative with just a little dash here. The derivative, let's say, is 6x squared minus 1. And I also tell you that f of 3 equals 51. And that will be important later. Okay, if I know the derivative, then how do I get the original? I have to anti-differentiate, I have to integrate. So what do I get here? 6x cubed over 3, which becomes 2x cubed, because it's 6 over 3. And then minus 1 becomes?
Minus x.
Yeah, and then?
Plus c.
Plus c. Now, this is normally where we would stop, normally. But in this question, we can continue. I can figure out the c. How?
If we substitute x with 51.
Yeah. Oh, no, try again. If
The
we
c.
substitute x for 3,
3.
I should get
51.
51. So 51 is supposed to be what I get here when I put in 3. So what's that? That's 54, isn't it? 54, 51. Is that right?
Yes.
So it's looking like, for this one, C turns out to be 0. No? Yes?
Yeah.
So I have my original function before it was differentiated. It was this. Okay. Now, sometimes they do ask you to find the C, but for some reason they don't do that in the semester 1 exam, even though it could be in the semester 1 exam. They usually wait for the final exam to give you a question like this. I don't know why. Even though it's a semester 1 topic. I don't know.
When you forget about it.
Exactly. When it's long gone. Yeah. But I think you get the idea. You sub in a point. Yeah. Just like how we normally get the C. You know?
And then if we got 51, for example, equals 50, c would be 1.
Yeah. So just in this case, it worked out to be 0. It's usually not, really. Okay. Have you... Okay. Barack, did you watch the tutorial video last week? You didn't watch it? Oh, I didn't think so, because I didn't get any comments from it. You should watch it, yeah. You should watch it.
There is a special mention.
That's it. You got a special mention in it, yeah. I was hoping you would like and comment on the video, but... Is this a good way to find out who doesn't watch the video?
It is.
Yeah, it's like, I could leave comments for people who aren't here. So, like, who isn't here? Joshua, well, let me tell you everything I find that's a problem with Joshua. Starting now. And you see, if there's no comment, then I know he didn't watch it. Okay.
Teacher, can you see who likes the video?
No. I don't think I can you? No, I'm not sure, actually. Yeah, I don't know. I definitely know who comments. I can see that. All right, did you write that down? See, now you're wondering, what did I say? You'll have to watch the tutorial you missed. Okay, right. Let me give you a few to try. They're not too bad. before I tell you which ones to try, I want to give you a couple of common mistakes I see in the exam. Okay, so I'll give you a quick one. Try this and let's see if anyone makes the mistake. So integrate, let's say, 1 over x squared plus 1 over x dx. Right, what do we get here? So the first one is 2x
Well, plus 3.
minus 1 over x, isn't it?
Yeah.
Minus 1 over x,
Yeah?
yeah.
Because this is x power minus 2. You increase and divide. Alright, so yes, you did make a mistake, so this is why I'm doing this
Nice.
one. And what's the next one? Log x.
Yeah.
Okay? Plus c. So what are the common mistakes I see? So I see sometimes people write log x squared plus log x plus c. I sometimes see people write minus 1 over x. The other one I like to see is x0 over 0 plus c.
Oh,
Okay.
nice.
The other thing I see is minus 1 over x plus log x without the c.
Amazing.
You know. No, you don't need to write these down. These are things not to do. These are wrong things to do. Okay. I don't know. It's a problem. I sometimes see this in the exam. You see, what happens is when students do this, they forget that this has a special rule. You know? Yeah? Okay, what I want you to try now, 1 BD, 2 COY. Y, 3A. There you go. 1, 2, 3, 4, 5, 6. 6 questions there. It shouldn't take you much time to do. Can you get a start on those?
Teacher, so if it's 1 over x, the rule is that you become log.
Yeah, actually, in case you're not clear, guys. 1 over x, the reason it's log is because it's like this. 1 over 1x plus 0. Right? That's the same thing, isn't it?
Yeah.
Yeah? And according to the rule I gave you, the rule, this is A and this is B. It's 1 over A log AX plus B. Or in other words, log x. But the other way you know it's log is go back to last week. What was the derivative of log x?
1 over x.
Therefore, the antiderivative of 1 over x is log x. It's literally, you're just doing the reverse. So if you know log x makes 1 over x, then you know 1 over x goes back to log x, yeah? Okay, try these 6 questions now.